पॉइंट वाइज हम लोग देखेंगे कि हाउ द एटम कैन बी क्लासिफाइड। सबसे अच्छी यूनिट है एटम, बहुत स्कोरिंग है। नंबर 1 जो यूजुअली क्वेश्चन आता है, ड्रॉ ग्राफ between number of alpha particle and scattering angle. And the graph looks like this. Here you have theta, here you have number of particles, and it goes like this. Maximum number of alpha particles will go undeviated, and very few alpha particles is having very large scattering of the angle of 90 degree or more than 90 degree. So this graph has two results. Number 1, maximum number of alpha particles go straight without any scattering. And number 2, a few particles suffer large angle scattering. दूसरे शब्दों में कहें तो ज्यादातर पार्ट जो है एटम का वो एम्प्टी है, और जो पॉजिटिव चार्ज है वो बहुत स्मॉल स्पेस के अंदर ही कॉन्सेंट्रेटेड है। द कंक्लूजन्स एंड रिजल्ट ऑफ दिस ग्राफ। कंसेप्ट नंबर 2 लो। Distance of closest approach. For numerical also as well as for theoretical, this result is usually there. Let's see this result. You have the positively charged nucleus here with charge Ze. I'm calling this to be Q1. Let the alpha particle of charge 2e will strike this. This is the minimum distance up to which the alpha particle will travel. And just after this distance it gets rebound. 180 degree का scattering angle ले लेता है यहाँ पर। It happened because इसकी जो kinetic energy थी वो completely convert हो गई potential energy में. So it is the distance at which kinetic energy converted into potential energy completely, पूरी की पूरी kinetic energy potential energy में convert हो गई। काइनेटिक एनर्जी का फॉर्मूला है हाफ ऑफ mv स्क्वायर, पोटेंशियल एनर्जी का फॉर्मूला है k q1 q2 अपॉन r। हमने इस डिस्टेंस को r नॉट नाम दे रखा है, तो वी आर पुटिंग इट r नॉट। सो व्हाट इज r नॉट? इट इज k q1 ze q2 2e upon half of mv square. This is distance of closest approach. It is the distance up to which any alpha particle can travel. Distance of closest approach. Now number 3. Third concept is impact parameter. Impact parameter. This is nucleus. Complete positive charge. This is the central line of the nucleus. This is the trajectory of the alpha particle. But the alpha particle can travel through any of this path. When you will take the perpendicular distance of this b1, b2 and so on, b से इसको डिनोट करते हैं, it is perpendicular distance between central line of nucleus and path, और हम यूज कर सकते हैं यहां पर वर्ड वेलोसिटी वेक्टर of alpha particle. This perpendicular distance is called impact parameter. The angle is called scattering angle. So what is relation between impact parameter and scattering angle? You will simply write that impact parameter is inversely proportional to scattering angle. More will be impact parameter, less will be scattering angle. Or more will be scattering angle, less will be impact parameter. Here you have 180 degree. Comparatively, this will be less than 180, then again less, it looks like this. And the perfect formula for B becomes, which is you will rarely get, ZE square cot theta by 2 upon 4 pi epsilon naught half of mv स्क्वायर। किसी भी पोजीशन पे अगर आप इम्पैक्ट पैरामीटर फाइंड करना चाहते हैं तो वी हैव अ जनरल फॉर्मूला दिस ze स्क्वायर cot थीटा बाय 2 अपॉन हाफ ऑफ mv स्क्वायर। Distance of closest approach, impact parameter, scattering angle. Number 4th, very common gold foil experiment in which we have a source of alpha particle, front we have gold nucleus or gold foil. We use gold because it is the perfect malleable material. Alpha particle will travel, well scattered in different directions. One detector is there which will detect all these variations. Some of the alpha particle may have more than 90-degree deflection also. Inside we have material called zinc sulfide. So when any alpha particle strike this, the scintillation will produce. That's why we have the ZNS. And this experiment is gold foil scattering experiment. Number 5. When we will equate Bohr it is based on 3 equations. First one, mv square by r is equal to kze square upon r square. That is, if positively charged nucleus is there, an electron is revolving around it in radius r, then the necessary centripetal force will be provided by electrostatic force between the nucleus and electron. Electron will revolve only in those orbits in which mvr is nh upon 2 pi. This is angular momentum. Must be equals to n times the constant h upon 2 pi. This will also support de Broglie hypothesis in the manner that 2 pi r must be equals to nh upon mv. So we can also state like this: electron will revolve only in those orbits in which circumference is multiple of lambda. C. Whenever electron make transition from higher to lower, it always radiates energy. It will jump from higher to lower. E2 here energy, even here, it always radiates energy. So what are the 3 postulates of Bohr atomic model? Number 1 is this: centripetal force will be balanced by electrostatic force. Angular momentum is multiple of h upon 2 pi, or 2 pi r is multiple of lambda. And third one is E2 minus E1 must be equals to h nu. So whenever electron jump, it always radiates energy. Some radiation, some transitions will be there. And the wavelength of that can be easily calculated with help of lambda equals to E2 minus E1 upon, or I must say lambda must be equals to Hc upon E2 minus E1. 3 important models Bohr are there. Number 6. Expression of radius and velocity. रिवॉल्विंग इलेक्ट्रॉन का रेडियस एंड वेलोसिटी निकालनी है. Starting from the first postulate, mv square by r. So r becomes 1. Second, so velocity becomes using the first and second postulate, you can easily equate radius and velocity. Put r from first to second. N h 2 pi m k z e square m v square. V becomes 2 pi kz e square upon nh. You can clearly see V is inversely proportional to n. This is expression for velocity. And when you put this expression of velocity in 1, इसका स्क्वायर रखना है 4 पाई स्क्वायर k स्क्वायर z स्क्वायर e4 n स्क्वायर h स्क्वायर. अब देखिए जो कैंसिल हो रहे हैं उन सबको कैंसिल करते हैं. k के साथ में k कैंसिल, z के साथ में z, e square also cancel out with this e square. So your final expression is n square h square upon 4 pi square m k z e square. Expression for radius. What I did here, velocity का ये expression इसके अंदर रख दिया मैंने, तो मेरे पास में ये expression. So finally I can write that the radius is n square h square upon 4 pi square m k z e square. I am calling this to be 4. First expression r and v, second expression v and r, third expression v independent of r, fourth expression r independent of v. When you simplify these expressions, v is 2 pi k e square upon h z upon n. We usually express in terms of velocity of light, so you simply multiply and divide with c. And here we have 1 upon 137. This is another universal constant. its value is 137. It is called fine structure constant. The fine structure constant looks like this. Maximum velocity must be there, which is there in the first orbit. Then it will be 1:2:1/3 ratio, where it will continuously reduces. So V1 is to V2 is to V3 is 1:1/2:1/3 and so on. जो वेलोसिटी पहले ऑर्बिट में है, दूसरे ऑर्बिट में उसकी 1/2 हो जाएगी, तीसरे में 1/3 हो जाएगी एंड सो ऑन. Similarly, if you simplify this expression, of radius, what you will get is nth orbit का radius आ रहा है h²/4π²m/k(E²) n²/z. This is 0.529 into 10⁻⁻10 if you will solve this expression. So it is R1 1:4:9 so on. सिंप्लीफाइड फॉर्म में हम यूजुअली लिखते हैं इसको 0.53 एंगस्ट्रम and square like that. Seventh point is expression for energy. If you will equate it, first of all, we have the kinetic energy of moving electron as half of mv square. From first postulate, we know mv square by r is kZe²/r². Just multiply with half. So this is the kinetic energy expression number 1. Potential energy K Q1 Q2 upon R0 or R. Positive Z is electron, nucleus and negative electron is revolving around it. So this potential energy becomes K ZE plus ka minus E upon R. This is minus of kZe²/r. So this is the kinetic energy expression and this will be potential energy expression. When you add both of them, total energy is minus half kZe²/r. 3 energies. means if total energy is minus 13.6 electron volt, kinetic energy and total energy, only negative sign difference is there. Kinetic energy becomes plus 13.6 electron volt, but potential energy minus of 27.2 electron volt. This is the difference. Kinetic, potential and total. This is NCERT numerical. Direct solve कर सकते हो आप इसका straightforward expression रख के, that kinetic energy is just positive of total energy, potential energy is 2 times of total energy. If you want to find the general expression of total energy, हमारे पास में R के लिए एक्सप्रेशन है माइनस R इज n स्क्वायर h स्क्वायर अपॉन 4 पाई स्क्वायर m k z e स्क्वायर. इसको अगर हम टोटल एनर्जी की फॉर्म में रखेंगे माइनस हाफ k z e स्क्वायर अपॉन, यहां पर रखूं अगर मैं तो दिस बिकम्स n स्क्वायर h स्क्वायर, और उसके बाद ये एक्सप्रेशन हमारे पास में आ जाएगा ऊपर 4 पाई स्क्वायर m k z e स्क्वायर. So once you simplified this expression, minus of 2 pi square m k square z square e 4 upon n square h square. When you simplify this expression, minus of 13.6 upon n square electron volt, provided z equals to 1. ये कहलाता है जनरल एक्सप्रेशन. इसी को अगर अपन जूल की टर्म में लेना चाहेंगे, it becomes minus 21.76 into 10 raised to power minus 19 joule. हर ऑर्बिट में टोटल एनर्जी डिफरेंट है. फर्स्ट ऑर्बिट की, जिसको ग्राउंड स्टेट कहते हैं, माइनस 13.6 इलेक्ट्रॉन वोल्ट. सेकेंड ऑर्बिट, जिसको फर्स्ट एक्साइटेड स्टेट बोलते हैं, थर्ड ऑर्बिट, जिसे सेकेंड एक्साइटेड स्टेट बोलते हैं, fourth orbit, and so on. We will get the different energy spectrums like this. 13.6 minus 3.4, all the energies are negative.